Part 3, the last part of section 1 of chapter 3. So the example here is the bank teller system. You know this example, we implemented this example in Excel and in chapter 2, but here we are going to simulate the system by the discrete event simulation, not the approach that we had in Excel. So you'll see what's the difference. So the number of tellers here is 1. There is just one line for waiting customers, and the customer mean arrival time is 5 minutes in average, the mean, and so the lambda for the exponential distribution will be 1/5. Okay, and the teller service time is normal with the mean of 4 minutes and the variance of 3 minutes. Okay, and so here we are going to simulate the system for 30 minutes. This is the first difference between discrete event simulation approach and the Excel approach. So as you remember, in Excel, we were tracking the customers one by one individually, right? So because of that, we simulated the system, like, let's say, for example, for 100 customers, right? But here, we simulate the system for a certain amount of time, for example, for 30 minutes, okay? And so at clock time 0, we assume that there is no customer in the system, the initial status, and these are the questions that we're going to answer by simulation. What's the teller or server downtime and utilization rate, and what's the average customer wait time? Okay, and here we have the interarrival time and service time in minutes for the customers. I mean, for 8 customers. Here we assume that we have generated these values based on their distribution. So these are somehow the random variables, right? Which actually we have generated by their distributions. So for customer number 1, the interval time is 5 minutes. Customer number 2 will arrive 6 minutes after the first customer, and so on. Okay. And these are the variables that we define in this example to simulate the system. LQT, the number of customers in queue at time t. LSC, server status at time t, will be 0 or 1. And C is cumulative completed services so far. And B, cumulative servers uptime so far. And W, cumulative waiting time so far. Okay. So here we have the manual simulation of the system. So as you see here, the first column in this table is the clock or simulation time. And as you remember in Excel, the first column for the customers, right? So we had one row for each customer. But here we are not actually tracking the customers one by one, and we advance the algorithm, advance the simulation by the time, right? So here we work based on the time. So we have the event type and so on. So at time 0, the event type is begin, so we start simulation. So there's no one in the system, so the number of customers in line is 0. The server is free at this time, and these two are our future event list. So based on the data, interarrival time, the arrival time of the first customer will be at time 5. And the end of simulation will be at time 30, right? And so since we are at time 0 and we know that the next event, the imminent event, is arrival of first customer will be occurred at time 5. So from 0 to 5, there will be no change in the system's state. So we advance the time from 0 to 5. So the next row will be for time 5, and we have arrival of first customer here. So since there is no one in the system, the server will start serving this customer right away. So the server's status becomes 1, busy. And as you remember, we said that at occurrence of any event, we will generate the next event. So when we have arrival, we will generate the event of arrival for the next customer. So as you see here, we have A2 at time 11. And also we have an activity here, right? The service of first customer has been started. So it's activity, the service time. So based on the service time, the end of this activity will be an event, and it's a departure. So departure of the first customer will be at time 8. So these two events will be added to the feature event list. And as you see here, we have 3 events now in our feature event list. Departure of the first customer at time 8, arrival of the second customer at time 11, and end of estimation at time 30, right? Again, we advance time from 5 to 8. The event type, time of the imminent event. So its type is departure. So we have the departure. There is no one in the line, so there will be no activity after this event, right? So because of that, we remove this event from the feature event list. So we'll have the 2 events in feature event list at time 8, which is arrival of the second customer at time 11 and end of estimation at time 30, right? So as you see here, the cumulative completed services becomes 1 here, and the cumulative server's uptime is 3 minutes. We are at time 8, and server was free for the first 5 minutes, so the uptime will be just 3 minutes, right? And the cumulative waiting time is 0, okay? So again, we advance time to time 11, the occurrence time of the next event, which is arrival of the second customer. And again, there is no one in the system, so server starts serving this customer right away, and its state changes to 1. And again, since it's arrival, we generate 2 events. The next arrival, A3 time 13, and since we have activity here, service time, so we need to generate the event of the end of this activity. So the departure of the second customer will be at time 14 based on its duration or service time, okay, and E30. And as you see here, the cumulative completed services is still 1. The cumulative actually servers uptime is still 3, and the waiting time is still 0. Okay, so by this by the same manner, you can follow the next rows to see how the time advance algorithm works here. So as you see here, now we see the difference between this approach, I mean this grid event approach, and the approach that we had in chapter 2. And you will see in the examples that we will have in this chapter that simulating systems, I mean complex systems, in Excel is not easy, right? It's hard. But here by this algorithm, we can easily actually simulate more complex systems. Okay, so that was an example, and we will have a live example in our live session, and for actually having more examples. Okay, thank you.